Difference between Uniform Memory Access (UMA) and Non-Uniform Memory Access (NUMA). Multiprocessors can be categorized into three shared memory model, which are Uniform Memory Access (UMA), Non-Uniform Memory Access (NUMA), Cache-only Memory Access (COMA). Uniform Memory Access (UMA) in UMA, where single memory controller is used. Uniform memory access is slower than non-uniform memory access. In uniform memory access, bandwidth is restricted or limited rather than non-uniform memory access. There are three types of buses used in uniform memory access, which are single, multiple, and crossbar. It is applicable for general-purpose applications and time-sharing applications. Advantages of UMA. Easy to implement. UMA architecture is relatively easy to implement, as all processors or cores have equal access to the memory pool. This makes it an ideal choice for small-scale systems, such as desktop computers or low-end servers. Low latency. Since all memory locations have equal access times, UMA provides low latency, which ensures that processors or cores can access memory quickly and efficiently. This makes UMA ideal for high-performance computing applications that require fast memory access. Low cost. UMA architecture is relatively inexpensive to implement, as it requires only a single shared memory bus to connect all processors or cores to the memory pool. This makes it an ideal choice for low-cost computing systems. Disadvantages of UMA. Limited scalability. UMA architecture is not scalable beyond a certain point, as adding more processors or cores to the system can cause contention for the memory bus. This can result in reduced system performance as processors or cores have to wait for memory access. Limited bandwidth. UMA architecture provides limited bandwidth, as all processors or cores share a single memory bus. This can result in reduced performance for memory-intensive applications. Limited memory capacity. UMA architecture provides limited memory capacity, as all processors or cores share a single memory pool. This can limit the amount of memory available to each processor or core, which can affect system performance. Non-uniform memory access. NUMA in NUMA, where different memory controller is used. Non-uniform memory access is faster than uniform memory access. Non-uniform memory access is applicable for real-time applications and time-critical applications. Advantages of a NUMA. Improved performance. By providing each processor with its own local memory, NUMA can reduce memory access times and improve overall system performance. Scalability. NUMA systems are highly scalable and can handle large workloads by adding additional processors and memory nodes. Reduced memory contention. NUMA can help reduce memory contention by allowing each processor to access its own local memory, reducing the need for multiple processors to access the same memory location. Disadvantages to NUMA. Complexity. NUMA systems can be complex to design and implement, as they require specialized hardware and software to manage memory access. Higher cost. NUMA systems can be more expensive than UMA systems due to the additional hardware and software required. Performance variability. In some cases, the performance of a NUMA system may be lower than that of a UMA system, especially if the workload requires frequent access to shared memory. Similarities. Both UMA and NUMA architectures are used in symmetric multiprocessing (SMP) systems where multiple processors share a common memory pool. Both UMA and NUMA architectures require memory management to ensure that all processors can access the memory they need. Both UMA and NUMA architectures require the use of cache memory to improve memory access times and reduce latency. Both UMA and NUMA architectures can be used in a wide range of applications, including scientific computing, database management, and high-performance computing. Both UMA and NUMA architectures can benefit from using high-speed interconnects to improve memory access times and reduce latency. Let's see the difference between UMA and NUMA. UMA. NUMA. 1. UMA stands for Uniform Memory Access. NUMA stands for Non-Uniform Memory Access. 2. In Uniform Memory Access, single memory controller is used. In Non-Uniform Memory Access, different memory controller is used. 3. Uniform memory access is slower than non-uniform memory access. Non-uniform memory access is faster than uniform memory access. 4. Uniform memory access has limited bandwidth. Non-uniform memory access has more bandwidth than uniform memory access. 5. Uniform memory access is applicable for general-purpose applications and time-sharing applications. Non-uniform memory access is applicable for real-time applications and time-critical applications. 6. In uniform memory access time is balanced or equal. In non-uniform memory access time is not equal. 7. There are three types of buses used in uniform memory access, which are single, multiple, and crossbar. While in non-uniform memory access, there are two types of buses used, which are tree and hierarchical. 8. Examples of UMA architecture: Sun Starfire servers, Compaq Alpha server, HPV series. Examples: NUMA architecture, Cray, TC2000, BBN, and others. UMA and NUMA are two different memory architectures that are used in computer systems. UMA provides equal access to memory for all processors and has lower latency, while NUMA provides higher scalability and better memory utilization. The choice between UMA and NUMA architecture depends on the specific requirements of the computer system and the workload it is expected to handle.